In the 6th geometry standard for 7th grade, students are asked to solve mathematical problems for area, volume, and surface area for 2D and 3D shapes. Much of this standard is a repeat from things that students have learned in 6th grade, and as they begin to complete some of these tasks, they will recall working with these formulas and these shapes in the 6th grade. In this standard, students should develop an understanding of why a formula works and how the formula relates back to its measures. It is not the focus of the standard for students to memorize the formulas. In the first task, Area Beyond Squares and Rectangles, students use grid paper to discover the relationship between rectangles and triangles and the formulas for area. Students will decompose a rectangle into 2 triangles to discover that the area of a triangle is half the area of a rectangle. Students will also decompose a trapezoid into 2 triangles to discover the relationship between the triangles and the trapezoid. After students cut out their rectangles and trapezoids, they decompose the shapes into triangles. Students then put their shapes back together to count up the number of units for each, and then they were able to determine the area for the whole shape and then for each individual triangle. Students then pasted their results in their composition notebook. It's important to note the standards of mathematical practice before beginning any task with students. Mathematically proficient students start by explaining to themselves the meaning of the problem and looking for an entry point into its solution. Standard 1 required for students to look at the relationship between the rectangles, trapezoids, and triangles that they were given. This standard also required students to be able to discover the formulas and then communicate that relationship back to their peers. Standard 7 requires students to look for and make use of structure. In this task, students were required to look at the big picture and decompose the parts down into smaller parts so that they could see repeating patterns within each of the rectangles, squares, and trapezoids that they were working with. This task is actually a task from the 6th grade frameworks. I pulled this task because it requires students to decompose shapes, make measurements, and determine the area of a composite shape. When I introduced this task to students, I did not provide them with instruction on how to decompose the shape. The only instructions they were given was to make measurements of the shape using millimeters and to calculate the area. Most of the students came within a reasonable margin of the actual area of the shape. If your 7th grade students completed this task in 6th grade, you could easily modify this task by creating a different shape and having students measure and calculate the area of the shape that you create. This task required students to use all 8 standards of mathematical practice. Standard 2 required students to manipulate the existing shape so that they could make a coherent representation of the problem at hand so that then they could attend to the meaning of the quantities. Standard 7 requires students to look for and make use of structure. In this task, students were required to look at the bigger picture and decompose the parts into smaller parts. Most students looked for a way to decompose their shape into the fewest parts possible, so they would have to do fewer calculations. In Task 3, students fill boxes with 1 centimeter cubes to explore the relationship between area, volume, and surface area. The first step in this task is for students to construct 4 different sized boxes. After students construct the boxes, they are asked to predict which box will hold the least amount of 1 centimeter cubes and which box will hold the greatest amount of 1 centimeter cubes, and to place them in order on their desk from least to greatest. Next, students are asked to predict the actual amount of 1 centimeter cubes that will fit into each of the boxes.
I think that one's just going to be like 1 tall. I think that's going to be one tall. I'm just guessing. I'm just putting down 100. It's going to have a lot. Maybe one tall. And then this one's like 60. That one's going to be a lot. No, but this is just one tall. Yeah, but the amount of cubes. So one tall would make.
Next, students fill the boxes with 1 centimeter cubes to determine the actual volume for each of the boxes.
So we didn't have enough cubes to fill the entire shape, so we just filled the height, the length, and the width.
After students determine the volume of each of the boxes, they then use the 1 centimeter cubes to help them discover the surface area of each of the cubes. Standard 3 requires students to construct viable arguments and critique the reasoning of others. Mathematically proficient students are able to compare 2 arguments and distinguish between correct logic and reasoning from that which is flawed. In the filling boxes task, students were required to listen to one another, especially in the predicting part, and construct viable arguments. Standard 5 requires students to use appropriate tools strategically. In this task, students used their constructed boxes, the 1-inch blocks, calculators, pencil, and paper. This task originally called for the use of Cuisenaire rods, and our school didn't have Cuisenaire rods, so we improvised with the 1-inch blocks. I think it's important to note that increasing the use of concrete and virtual manipulatives develops every student's mathematical proficiency. Using manipulatives allows students to construct their own cognitive models. Manipulatives are engaging, and anytime a student is engaged, their interest is increased and their enjoyment of math goes up. In Task 4, Bigger and Bigger Cubes, students build cubes to explore the relationship between the volume of cubes and the surface area of cubes as the cubes get bigger. Students begin the task by looking at a 1 centimeter by 1 centimeter cube, and we talk about what would happen if we doubled the cube. And so then students build a 2 centimeter by 2 centimeter cube, and then a 3 centimeter by 3 centimeter cube, until the cubes continue to get bigger. Eventually, the cubes get so big that we don't have enough 1 centimeter by 1 centimeter cubes to make the larger cubes, but students begin to understand the relationship between the length, the width, and the height. This is a great activity to segue into perfect cubes for 8th grade, and it's also an excellent way for students to explore the relationship between surface area and volume of cubes. Standard 3 requires students to construct viable arguments. In this task, students had to explain their thinking to one another, and they had to analyze their situation by breaking it into parts and communicate that to others. They also had to respond to the arguments of others working within their group. Mathematically proficient students look closely to discern a pattern or structure. In this task, students looked for patterns that would show up as their cubes got bigger, and this helped them when they moved on to rectangles. This also lends itself to an excellent opportunity to begin talking to students about perfect squares and perfect cubes.